Mr. Cunningham,
Yes, sir.
just to let you know, I've been fighting with the Wi-Fi all day long today.
Okay.
So I'm hoping I'll be here, but if something happens, I'll just jump right back in.
Okay. I am recording now, so I'll have to get you the link for Tuesday as well. See that, but I'll send tonight's link for sure. Give me 1 second. Darn it, let me pause the. So 5C. Tables. And graphs. So we are, this is all the point of organizing and consolidating data that I may have collected, the raw data I may have collected. Okay, so we're going to start with what we call frequency tables. Okay, so a frequency table has a basic frequency table has 2 columns. Right. First column lists categories of data. And the second column lists the frequency for each category. Which is simply the number of data values within that category. So, an example of a simple basic frequency table may be a class and their grades. So I could have, the categories in this example would be grades given for taking a course, which would be A, B, C, F, and then over here, you would second column again would just simply be your frequency. So let's say there were 4 A's, 7 B's, 9 C's, 3 D's, and 2 F's, and then you could total up that the frequency column, get 25, and that would match the number of students within the class. So just a simple way to organize your data. Now, that's your basic table. Now you can add columns to this table. I could have a column, another column, which I'm going to call relative frequency. All right, so now this is a term we have used actually a good bit throughout the semester, aside from just statistics. When I use that term relative frequency, or what am I talking about? It begins with the letter P. Big long word, letter P. spent a lot of time taking, it has a symbol, big hint, looks like this. So what is that symbol for?
Percent.
Percentages. Okay. I'm sorry. I should not make you talk.
No, it's okay.
I'm just being mean now. You can chat it in. So you know, I can tell your voice is stressed. But yeah, it's just simply, so when we're talking about a relative frequency, we're simply talking about percentage. So we could, you know, there were a total of 25. And so we could write as a ratio. For A's, it's 4 out of 25. For B's, it's 7 out of 25. For C's, it would be 9 out of 25. And then, of course, 3 out of 25, and then 2 out of 25. And that's writing those ratios. Now, we could actually then get our calculators. Go 4 divided by 25. Now, it's going to give it as a decimal, 0.16. And then move the decimal place twice and write it as a percentage, or we could say the relative frequency is 16%, or 0.28, or 28%. 9 out of 25 would be 36%. 3 out of 25 would be 12%. And 2 out of 25 would be 8%. Now, because these all were all, you know, how it broke down to the total number of students in the class, that column has to, first off, all these fractions would add up to be 25 over 25, or 1. And the percentages would all have to add up to be 100%. Now, another column that you will see added on frequency tables is cumulative frequency. Cumulative frequency. Okay, so now this is just frequency, so it's not percentage. It's not like relative frequency. It's just, and the word cumulative means we are adding as we go. So the way this would work is the first number here would be 4. Now it's cumulative. So when the next number is 7, so what you would end up with here is 7 plus 4, or most of the time you would just see 11. Let me put that 4 here, erase the other one. So generally you wouldn't see the 7 plus 4. I just wanted to show where it's coming from. So the next one would be 11. So the next one after that would be adding on the 9. And so 9 plus 11 is 20. The next one would be 23, because you would be adding on the 3. And the last one, of course, would be 25 for a total of. And so this last number in the column would be the total. And again, that's referred to as cumulative frequency. All right. Any questions thus far? Okay. Now, when we're dealing with data, raw data that we have collected, there are 2 types. So data types. We could have what we refer to as qualitative and what we refer to as quantitative. Okay. Now, qualitative data consists of values. So I mean, these are numbers that can be placed into non-numerical categories. And quantitative data represents counts, things I've counted up, or measurements. All right. Now, there are times we won't see this until we hit histograms towards the end. But when using quantitative data categories, it's often useful to group or no key, this word we want to use here, or bend the data into categories that cover a range of possible values. Okay, so as an example, if I were looking at income levels, I may have one bin that goes 0 to $19,999. So example, and that would be one bin, no dollars to $19,999, and then have another bin, and it would pick up right at what, 20,000, and then see how I'm keeping these bin links, 20,000, then 20,000 in terms of the links there. So the next one would have to go from, say, 40,000 to, that would be what, 59.99, and so forth and so on. These again are referred to as bins. And so then I go through all my data, and any, in this case, income that fell between here and here would go into this bin. And any data value that was between here and here would go into this bin, so forth and so on. And then you would just basically have, the number of data values that fell into here and the number of data values that fell into here, and or what we call the frequency, and so forth and so on. Okay, so let's say I had, as another example of this binning that I'm talking about, binning the data, BINNING. Let's say I had 20 scores on a 100 point exam. Okay, so now I'm actually going to jot them down here. There's 20 of them, 76, then 80, 78, and then 76, 94, 75, 98, 77, 84, 88, 81, 72, 91, 72, 74, 86, 79, 88, 72, and 75. So it should be 20 scores. 1, 2, 3, 4, 5. This one was a 90. It's not a 70, it's a 94. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. All right, so there are 20 scores there. And so I'm going to construct a frequency table like we've been talking about. Okay, so frequency table for, and I'm going to bend them. So I'm going to say bend exam scores. All right. And so I will have a column here that says scores, but I'm going to bend them 95 to 99. Now that would be 95, 96, 97, 98, 99, or that's 5. So, or what we're going to call, now, so this wouldn't be part of the table, but I'm going to call a 5-point bends. And again, it's because if you start at 95, it's 95, 96, 97, 98, 99. So there's 5 different scores that could fall within that bend. And all of them will be like this. So going down that line, and I chose 99. Now, if somebody had scored 100, I would have to take that to 100, but the highest score actually I see in that list is 94. So it definitely would fall. And you always want these bends to be, you know, whatever point, 4 point, 5 point, 6 point, whatever. All the bends have that same width about them. So the next bend would be 90 to 94. Again, there's 5 points there. And then you would have 85 to 89, 80 to 84, 75 to 79, and 70 to 74. Now, I don't see any scores in my list of 20 scores below 70, so I don't need to make any more. Once I've got my bin set, I can then have another column, and this would be simply the frequency. So all the scores that fall within this bin, all the scores that fall within this bin, and whatever I come up with, the total here will be 20. I couldn't have any more than 20. So if you would have to, if you're doing this by hand, to set and count up the number of scores between 95 and 99 and check them off once you've used them. But in this case, it works out to be 1, 2, 3, 3, 7. We're between 75 and 79, and 4, we're between 70 and 74. And if we add this up, that's 6, 9, 16 plus 4 is in fact 20. Right, then I could have a relative frequency column. Abbreviate here. And that was supposed to be a decimal point, not a slash mark. Relative frequency. And so again, this would be 1 out of 20, 2 out of 20, 3 out of 20. You don't really have to write those. I'm not going to even write them as percentages. I'm going to write them in their decimal form. 1 over 20 is 0.05. Okay. 2 out of 20 is 0.10. 3 out of 20 is 0.15. 3 out of 20 again is 0.15. 7 out of 20 is 0.35. And 4 out of 20 is 0.20 or 0.2. So say 0.20. Now, if I had them as percentages, that would have been 5%, 10%, 15%, 15%, 35%, 20%. They would all add up to be 100%. If you leave them in their decimal form, they wouldn't add up to be 100%. They would add up to be 1. Again, note, if I move the decimal place twice, I'd have 100%. All right. Then my cumulative frequency would be, again, you start with 1. Now remember, what I'm going to do is add each time going down the list. So this next number would be 3, or it would have been 1 plus 2. The next one would be 6. Next one would be 6 plus 3, which is 9. Then 9 plus 7 is 16. And 16 plus 4 is 20. And again, that last number should match up with this number here. Okay, questions on that one? So frequency table, and now we've looked at the 2 extra things we can throw in there: relative frequency and cumulative frequency, and then the idea of organizing it in what we might call bins if it's quantitative data, such as this. Okay. All right, so let's talk about, and again, you would use binning again for quantitative data. So let's talk about a couple graphs and charts that we might use for quantitative data, or qualitative data, excuse me. All right, so we're going to refer to them as bar graphs and pie charts. And they are used for qualitative data. All right, now when we have dealing with well, let's just say for graphs, bar graph. Oh, man, I cannot write. Important. Labels for bar graphs. All right, so important labels for bar graphs. Have a title, right? Or some sort of caption. Right. So, or both, that explains what is being shown, and if applicable, lists the source of the data. Where did you pull the data from? Then we want to have vertical, scale, and title. So, and what we mean there, if we're setting up a bar graph, you're going to end up with something like this. And then we're going to have some bars in between here, but along this vertical, on a vertical scale, we would want when we say scale, there's a clear way the numbers are increasing up the vertical axis. And these numbers will line up with uniform, what we call tick marks. That is boom, 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 boom. I may go 2, 4, 6, 8, 10, 12, 14. I may go 1, 2, 3, 4, 5, 6, 7, etc. But it's uniform. And then you also want to have an axis title here that clearly describes what the numbers represent. And now that may be a frequency, that may not be. In the case of, where I have frequencies that I'm trying to measure off here, I may actually on this other column do relative frequencies. You can see that. Okay. And we'll look at an example here in a second, specific example now, but I also have a horizontal axis on this thing. So I want to have a horizontal scale and title. And these categories should be clearly indicated along the horizontal axis. The categories in question. And tick marks here, because it's qualitative data, these categories are qualitative. You're not going to need any tick marks. You're not going to have any numbers. Just the categories are going to be listed out. But you would need them for, obviously, for quantitative data. You're going to have an axis title that describes, the variables that the categories represent. And you may need a legend somewhere if there's multiple data sets are displayed on a single graph, including a legend and a key to identify individual data sets. So if I had that example of the frequency table that I had on the previous page, that were the 20 grades, and this were going to be my bar graph, then I may, those grades were for some essay, so I would have a title. It would be essay grade data. And up the vertical here, well, this is hard. I would have frequency of grades. That's very hard to write vertically on with my tablet. And on this one, I'm going to put, this isn't necessary, but you could have the relative frequency, which remember would just be the frequency over the total, which in this case was 20. And then uniformly spaced, you have A, B, C, D, and F. Now there were 4 A's. Oh, wait a second. I think this wasn't our Venn data. This is it. This is qualitative. This was the 25 grades for essay, the one we started with initially, and there were 4 A's there. So I would have a bar. Now I would also number here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll take this to 10. So this would go up to 4 for the A's. Now on a bar graph, between the bars, there is a space. So B's, there were 7. Bar going up to 7. It would look like straight lines. And these bars go to the wherever the height of the frequency. In this case, there were 9 C's, so I would go up to 9. D's, there were 3. And F's, there were 2. So up to 2, and so on and so forth. All right, and of course, I would have a title here on that horizontal and say grade. All right, now I could also do what is called, again, a pie chart. Now, this even gets worse. That's actually fairly good for me to freehand. And I draw a circle. Now every circle has got a center. And so these, say there were 5 grades, I'm going to chunk this off into 5 sectors, and they would be proportional to their relative frequency. So in this case, I might do that. And then I would, again, I would want a title, essay grade data. So it's still the same data. And then I would simply do this. Now there were more C's than anyone else, any other grade. Notice this is the largest piece of pie. We're going to talk a minute about how you come up with if you were going to freehand, or do this, draw this by hand. But 9 out of 25 is 36%. 0.36, move the decimal place twice. Or these are those relative frequencies. D was 12%. F was 8%. A was 16%. And B was 28%. All right. Now, how do I figure out if I were going to construct a pie chart by hand? A circle going all the way around in degree measures how many degrees? Any takers? You go all the way around the circle with my pencil. The one full lap around. All right. Does that ring bells? 360 degrees all the way around in a circle?
Yeah, it does.
Okay.
Yeah. Sorry, I was trying to find a way to unmute my mic.
Oh, you're good. So to figure out, how to exactly make this proportional, 36% of the whole circle, you would take 360 degrees times 0.36 as an example to get this one. Now, so I just take my calculator.
Taking them into a decimal,
Yes.
like
So,
each one of them.
so before you multiply the 360 degrees by 36%, you would write it as a decimal.
Okay.
And take your calculator and you're just going to punch in 360 times 0.36. Now what you get is 129.6. So what I'm going to do, I'm going to round that. And I didn't mean to put a percentage sign there. This is degrees, or 30%, 36% of 360 degrees is 129.6 degrees. And I'm just going to round that up to 130 degrees. Now, we all familiar with the protractor?
A tiny bit.
Okay.
I always had trouble with it.
I'm almost positive I do not have a protractor here where I'm sitting. I've got them at college. Protractor is simply a device to measure and actually draw an angle of such and such measurement. Kind of looks like this. Half an arc, comes over, it's got a center here, and you've got your degree marks from 0 over to 180 degrees. So it's 180 degrees. And so wherever the vertex of the angle is going to be, you would set your protractor, and generally there'll be a side like that. And these degree markings again go 0, 1 degree, 2 degrees, all the way over to 180 degrees. And you would set this protractor down on the center of, you draw that circle. I would use like a compass, make a nice big circle that's uniform. Set the middle point of this right on here, and I could draw out one thing here. And so like 36 or 130 degrees would roughly be about, like, you would find it about right here. And you would then mark that other side. Notice that I didn't exactly put it in the same place. Doesn't have to be, but it's roughly about what that one looks like. And then that's 36% of the whole circle. So that's the way you would hand construct them. Of course, there are computer programs that will, you supply what the percentages are, what those relative frequencies are for each category, and it will figure up what the percentages times 360 are, and just put them together for you. Okay. So, but that's if you had to, what the computer program is, again, how it makes it proportional. Okay. Any questions on either of these two? Bar graph, pie charts. Okay. Okay. Well, so now again, bar graphs, pie charts are for qualitative data. So quantitative data. Quantitative data. What we're going to call histograms and line charts. Metrology charts. Histograms and line charts are for quantitative data. So if, let's say I want to construct a histogram at this time for the, where I had the 20 grades listed out, and then I bend them into those 5-point bends. And so a histogram for that one would look like this. And then on the horizontal, I'm going to put those bends. Now, the bends, if we remember, I'm going to flip back to that. These were the bends: 70 to 74, 75 to 79, 80 to 84, etc. All right, so when I put these together, it's 5-point bends. I want to go 70, then 75, then 80, then 85, 90, 95, and then 100. Okay. Now this column, so these are gonna again be represented as scores. Title, we're just gonna call grades or exam scores. So it's a better way to put it. So exam scores. And up this column on this axis. Oh, it's hard to write there that way. Frequency. And so it's going to go 0, 1, 2, 3, 4, 5, and these should be uniform, but I'm hand drawing them, so 8, 9, 10. All right. Now, I'm going to flip back to that frequency table, the bend frequency table. So between 70 and 74, there were 4. Between 75 and 79, there were 7. So now let's flip back to where I'm constructing this table. So watch how I'm going to start at the 70. I'm going to go up to 4. Between 70 and 74, there were 4. Come across, come down like that. Now remember, between 75 and 79, there were 7. So no space between the bar. I'm just going to pick up right here, shoot up to 7, and then bring my bar back down here. So how do I interpret it? Everything between 70 and 74 goes here. It's between 75 and 79, that is once I hit this one, now that's how I know anything, which there were 7 of them, they have to be in that bin. So when you have your frequency table, bin frequency table, it's going to go 70 up to 74. When you actually then construct this histogram to represent it, this bar, you put your first one in, then you know that this side right here, the 75 goes to this bin. That is the 75 to 79. Between 80 and 85, I do not remember. I'm going to have to flip back. And between 85 and 89, there were just 3. So the next bar will be right here. And then one right after that was also 3. Now between 90 and 94, excuse me, there were 3, there were 2. And then 1. So this one would go from 90 to 94. And then there was just what? 1 between 95 and 99. And that's again referred to as a histogram. So, you can visually tell, is it a bar graph or a histogram without looking at anything else. And when you look at the bars on a bar graph, those bars there's space between them. On a histogram, no space, but there can't be. It's the nature of the bends. All right, now I could do what's called a line chart with the same data. And it would look like this. Now I would have the same horizontal. Everything would look the same. I would have 70, 75, 80, 85, 90, 95, and 100. I would have my frequencies. I have 0 and 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. Now, remember between 70 and 75, there were what, 4? But I don't, so this is going to be my line, and these are again exam scores. So there's my title. Between 70 and 74, there were 4. But I don't draw a big bar like I did on the histogram. For this line chart, I go right to the middle between 70 and 75. I'm just going to put a dot, and your eyeball halfway between. Between 75 and 79, there were, I believe, 7. So I go in again, visually 7. Go up to here halfway between 75 and 80, and I put another point at 7. 7. Then it was about fell to 3. So I would be here. Next one was 3, halfway between there. And then it went to 2, and then it went to 1. Then starting here, I play connect the dot with straight lines. Oh boy. I can't draw to save my life. Try to go from here to here. Up to here. Down to here. Down to here. And then I go to just go right off into the corner of my table. And this again is referred to as a line chart. And you literally could actually put these points in because they would, off the histogram, they would all fall right in the middle of the top of each of these rectangles. Okay. So there is also what you can have referred to as a time series graph. And on a time series graph, it's a line chart or histogram in which the horizontal axis represents time. It's just that simple. So that horizontal is going to represent time. And so an example may be like if I were looking at the U.S. homicide rate from 1960 to 2016. I'll turn the page. And I'm going to do a rough facsimile of this. Again, this is going to be an example of what's called a time series graph. And now, so again, this is US homicide rate. US homicide rate. Now, here I'm going to put what the vertical axis is going to represent, and this is going to be the homicide rate per 100,000 people. Okay, so I have 0, then 4. Notice I'm putting a little more space than I did here and here. And then up to 8. That is 8 out of 100,000 people. 10, 12. So I tried to keep all these roughly the same. This one is definitely much shorter. And so if there's this right here is not uniform with the rest of these between the tick marks, what's happening is I've skipped numbers. And so if you see 2 little slash marks like that, that means you have skipped some numbers. Now here, I don't want to draw all these out or write every single one of them. But remember, time series graph, this represents times. In this case, years, 1960. Then say 1962, and then between 1962 and 1964 and 1966, then 1968, and say this ran all the way up here to 2016 at the end of it anyway. But what I would do is I would have at EN, there's tick marks in between, and that's for 61, 63, the odd years. So you can see the tick marks there. Then for each year, say 1960, and I misdrew that. Damn it. All right, that's actually 61. Here's 1960. And that's 61. Yeah. That's 1960. 1961, 1962, 63. Okay, so on and so forth. So that's 1962 here. Anyhow, and this, you would put all these years in. And the reason I'm not writing the odd years is just, it would get real. You can see how, you know, with my writing, they're getting jammed together, but you would have the tick marks here for each year. Now, each year you would put whatever the homicide rate was for so let's say like right here, let's say it was 5 per 100,000. And then let's say in 61, it dropped down a little bit. And it kept dropping in 62. It was here, but each year you would put how many, you know, how many ever it was, whatever the frequency was. And eventually you would play connect the dot. And that's how you can see trends of, hey, it's trending up or it's trending down, so on and so forth. All right, that's not the best drawing I ever did, but that again, if that horizontal axis that would be referred to as a time series graph. Okay. Any questions on all that?
I don't think so.
Okay.